Find the area of the cardioid. So r of theta equals 1 plus sine of theta. And we're going to need this later on. Sine squared of x equals 1/2 times 1 minus cosine 2x. So here's the cardioid, and here is 1 plus sine of theta graphed 0 to 2 pi. It does take 0 to 2 pi to trace out the entire cardioid. And sorry, we start there at 0, go around, and eventually get back to 2 pi. And right, that little corner edge there is right there. This is the top. And we've got this one here is that. This one over here at the same height will be this one here. All right, so you go through and you trace the whole thing. So let's write down the integral in polar form. It's already given to us pretty much because we have the shape in polar coordinates. So we'll have integral, and we're going to have 0 to 2 pi. That's going to be theta. Then we're going to have 0 to 1 plus sine of theta. And we're integrating area, so it's 1 times r dr d theta. All right, so first integral, not too bad. We get integral 0 to 2 pi. Okay, we integrate r, we're going to get 1/2 r squared. And then we're going to evaluate that from 0 to 1 plus sine of theta. And we still have our d theta at the end here. All right, so coming down here, let's see. All right, so plugging in 0 for r, we'll get nothing, so we don't have to worry about that bound. So really we have 1/2 and then times 1 plus sine of theta squared. Sorry, I forgot my integral in front, so 0 to 2 pi d theta. Okay, we're going to have to expand that out and simplify. So that's going to equal, let's see, I'll take the 1/2 out front. So 1/2 integral 0 to 2 pi. Okay, so we'll get 1 times 1, so 1. We'll get 2 sine in the middle, sine of theta. And then we'll get sine times sine, so we'll get plus sine squared of theta. And then at the end we'll have our d theta. All right, I might need a little more, I'll just go down here. Okay, equals. All right, so we have to get that sine squared to be a little nicer, which is where this trig identity will come in. So it's 1/2 still, integral 0 to 2 pi. We have 1 plus 2 sine theta. All right, plus 1/2 times 1 minus cosine of 2 theta. d theta. All right, so now let's simplify a little more if we can. Not a whole lot. So we have our 1/2 integral 0 to 2 pi. All right, so we have a 1/2 plus a 1, so that 1 in front becomes a 3/2. And then plus 2 sine theta. And we have a 1/2 minus cosine 2 theta. Okay, d theta. Okay, now we can integrate everything. So that's 1/2, and I'll need square brackets this time. Okay, 3/2 integral. It's going to be 3/2 theta. All right. We have plus 2 sine, so then that's actually going to be minus 2 cosine of theta. We have our minus 1/2, so it's going to be minus 1/4 sine of 2 theta. And that's evaluated from 0 to 2 pi. All right, so we have 1/2 here. All right, so let's see. So we've got 3/2 times 2 pi minus 2 times cosine of 2 pi minus 1/4 times sine of 4 pi. Then we'll have a minus. I think I can squeeze this in. I might as well write it out here. So it's 3/2 times 0 minus 2 cosine of 0 minus 1/4 sine of 0. All right, and parenthesis and square bracket. Okay, so then down here I still have my 1/2. So let's see. I've got 3 pi from that first term. Let's see, cosine of 2 pi. Cosine of 2 pi is 1. Yeah, so that's minus 2. Then I have sine of 4 pi. Well, that's 0. And then I have a minus, well, 3/2. Okay, so I have a minus minus cosine of 0. So that ends up being a plus 2 times 1. So plus 2. And then I've got sine of 0 ends up being 0. Okay, so then equals, then minus 2 and the plus 2 cancel. And then we're just left with 3 pi over 2. There you have it. That's apparently the area of the cardioid.